All right, for our next example, we're going to find the Laplace transform of the cosine function. And this can be found a bunch of different ways. The easiest way to do it is to actually use Euler's formula for the cosine function, which uses the complex exponential. So that's going to be the Laplace transform of the sum e to the I bt plus e to the negative I times b times t, all divided by 2. And we're going to find the Laplace transform of this. And if you look at it, it's just a sum of two exponential functions divided by 2. So we can use linearity to actually go ahead and find the Laplace transform without breaking into the definition with integrals. And we could actually use integrals here, and you could either integrate with exponential functions or integrate by parts with cosine, but it's a lot of work. And this is definitely the easier way to go about it. So let's go ahead and use this instead. So when we do this, we're going to have 1/2 of the sum of the two individual Laplace transforms, e to the ibt plus 1/2 Laplace transform of e to the negative ibt. Now, from our previous example, we saw that these were just going to be 1 over s minus whatever coefficients here. So that's s minus ib. And then the other one is going to be 1 over s minus negative ib. So that's going to be plus ib. All right, and now we can go ahead and actually add these two together with common denominators. So we get 1/2 of the sum, multiplying the top and bottom by this. We get plus s plus ib. And then back here, multiplying top and bottom, s minus ib. And then over the product, s minus ib and s plus ib. We can then go ahead and combine like terms. Adding upstairs, we end up with the s's doubling up and the ib's canceling out. So that's going to make 2s. And then downstairs, we actually have the difference of squares. So that's going to be s squared minus I squared b squared. And we all know from complex numbers that that's actually I squared is -1. So that becomes an s squared plus a b squared. And then we'll notice that the 2's cancel. So we end up with s over s squared plus b squared. And that right there is the Laplace transform of the cosine of bt.